You ever see a drone just hang there in the air, perfectly still, and then zip away in an instant, and you just think, how? How is that even possible? It honestly looks like magic. Well, today, we're going to pull back the curtain, and we're using the fantastic book, Make Drones, as our guide. We're going to break down not just how they fly, but how you can teach a machine to fly. I love this quote from the author, David McGriffy. It just nails it. A drone isn't some graceful, delicate thing gliding on the wind. Nope, it's a brawler. It's a marvel of pure, raw power and lightning-fast calculations that literally forces the air to do what it wants. So what's behind it? It feels like magic, but it's all engineering. And what's so wild is that this whole revolution in flight didn't come from one single big invention. Nah, it was the result of a few key technologies all finally getting good enough at the exact same time. A perfect storm, really.
So let's dive into that breakthrough. It wasn't one giant leap for mankind. Instead, it was the convergence of three pretty simple but powerful innovations. And once you get these three pillars, you're on your way to building your own.
And here they are, the big three. First, we finally got motors that were suddenly light enough to lift themselves, but were still incredibly powerful. Second, batteries that could pack a huge punch from a tiny, lightweight package. And finally, the real secret sauce, the tiny, miniaturized brains of the operation that could make thousands of decisions every single second to keep the things stable.
Let's start with those motors. The key idea here was a brilliant trade-off. See, engineers realized that for flying, being lightweight is way, way more important than being perfectly efficient. So they just took out the heavy iron core. It's a simple change, really, but it was an absolute game changer for getting these things off the ground. Next up, the fuel. The world's lightest motors are useless if you don't have a power source that can keep up. And LiPo batteries were the answer. It's not just that they store a lot of energy for their size, it's that they can discharge that power incredibly fast. That's what gives a drone the instant bursts of power it needs to stay stable and zip around. And here it is, the final piece of the puzzle, the brain. A quadcopter is naturally unstable. It basically wants to flip over all the time. What keeps it in the air is this tiny little chip. It's basically the drone's inner ear, a combination of a gyroscope and an accelerometer that tells the flight controller which way is up, thousands of times a second. This is what makes stable flight even possible. Okay, so now we get the core ideas, right? Motors, batteries, brains. But how do you actually go from knowing the theory to doing it? Well, the book suggests a brilliant starting point. Don't build from scratch. Not yet. Instead, start small. Take a drone that already exists and upgrade it. It's the best way to get your hands dirty and really learn the fundamentals.
And the very first step to improving anything is to measure it, to see what it can do right now. So we're going to use a super popular little micro drone, the Hubsan X4, as our test subject. And the first experiment is really simple. What happens to its flight time if we just swap the battery?
Okay, so here's the raw data from the tests. We tried 3 different batteries, a smaller one, the stock one, and a larger one. And the takeaway is pretty clear, right? As the battery's capacity and its weight goes up, so does the hover time. We go from just under 5 minutes all the way up to nearly 7.5. This chart just makes the trend totally obvious. Bigger battery, more time in the air. So the solution seems easy, right? Just slap the biggest battery you can find on there and call it a day. But, as with everything in engineering, there's always a catch. And here is that catch. There's always a trade-off. That extra weight from the bigger battery, it makes the drone feel sluggish, it's less responsive, less agile. So now you've got your first real design choice as a drone maker. Do you want more flight time or do you want better performance? All right, so once you've gotten the hang of modifying and testing, you're ready for the next step, building. We're actually going to use the same drone frame, but this time we're doing a brain transplant. We're ripping out the old controller and putting in a new open source one that gives us complete control. This little project, called the X4We, basically breaks down into 4 main steps. First, you flash the new software onto the controller. Then you do a little bit of simple soldering to connect everything up. After you put it all back in the frame, the real fun starts, tuning. That's where you tweak the software to make the drone fly exactly how you want it to. And that tuning part is so important because the real magic of a custom build, it isn't in the hardware, it's in the software. This is where you can fundamentally change the drone's entire personality, how it behaves, what it can do. It's pretty amazing. One of the biggest perks of a custom controller is getting access to different flight modes. This means you can actually program how the drone behaves. You can set it to be super stable and easy to fly for a beginner, or you can unleash its full acrobatic potential. The training wheels analogy is honestly the perfect way to think about the two main flight modes. Angle mode is like flying with training wheels on. If you let go of the sticks, the drone just automatically levels itself out. It's safe, it's stable. But rate mode, well, that's when the training wheels come off. Now your sticks control the rate of rotation, which gives you the freedom to do flips, rolls, full-on acrobatics. Now, you might be thinking, this is all cool, but it's just about tiny little drones. But here's the thing. The skills you learn here, understanding motors, batteries, controllers, tuning software, these are the exact same principles used to build much, much bigger and more sophisticated machines.
And the book lays out this awesome path to mastery. You start with this little microdrone, then you scale up to a more capable, custom build, and eventually you can tackle something like this S500, a powerful rig capable of autonomous flight and carrying a professional camera.
And this right here, this quote really gets to the heart of the whole book. It's this powerful idea that even something that seems impossibly complex, like a drone's flight controller, can be broken down into simple, understandable parts. Once you get that, you realize you have the power to build and understand almost anything.
So, what started out as this mysterious black box of technology is now a set of principles that you can understand. You now have the foundational knowledge to take a few simple components and literally teach a machine to fly. The only question left is, what are you going to build?